Hello everyone, I'm Pekka. I'm here to talk about OSV. Thank you. It's a new operating system for the cloud. This talk is actually divided in two parts. I will first talk about OSV core and where we're at right now. And then Zach will join the stage to talk about the configuration and management and a little bit about the future. I'm the co-maintainer of OSV, so if you send patches, I'm probably the one to merge them. So a few words about Claudius. It was founded in December 2012 by fathers of KVM, or the kings of KVM, as the register proclaimed. We're currently 14 people in 7 different countries. All the code is open source, available on GitHub for everyone to use. And we actually joined Linux Foundation last December. Our mission is to build the best operating system to power virtual machines in the cloud. So that means that we are expecting to run on top of a hypervisor and not writing an operating system to run on bare metal. So what is OSV? It's a cloud operating system, or we like to call it a cloud operating system, written from scratch. No, we did not fork Linux or any other operating system. Objectivity wrote really all the bootloader stuff and everything from scratch. We did take a networking stack from BSD, like everyone else does, and we also imported CFS. We're actually modifying the networking stack quite heavily to support network channels, which I will go into more detail a bit later. CFS we obviously didn't change, and we're hoping to switch to OpenCFS at some point. And yeah, we use C++11 extensively, which is always a bit of a shock for people coming from Linux kernel background. So why did we decide to write a completely new operating system and not use one of the existing ones? If you look at the typical cloud stack, you see, well, actually you see it quite poorly here, but you see duplication between different layers. So the hypervisor operating system, like Linux, for example, JVM, all three provide protection and abstraction, so sandboxing. Oh, it wasn't a question. So, and actually, I think this is one of the big reasons why people are looking into container-based virtualizing solutions, because obviously this causes some amount of overhead, and it's actually not that useful for the guys upstairs trying to just put their application on the cloud. So OSV uses a slightly different approach to traditional operating systems. It's a library-like design. It's not a new idea. It was pioneered in the 90s with exokernels, but it actually has become a viable solution now because when you're running on top of a hypervisor, you don't need that many device drivers. So what it means is a single application per virtual machine. There's no kernel user space separation, like so basically everything is running in ring 0. No fork, obviously, but because we're running directly on top of the hypervisor, you can access things like MMU via our own APIs. We do support POSIX APIs for compatibility, which I will go into more detail later. So effectively, what we've done is we've collapsed, for Claudius specific case, JVM and the operating system into one layer. So we have one layer less. Features. So what can you expect from running your application, or what can you expect from OSV when you're running your application? We actually support all the sort of operating system services you would expect from a modern operating system. So we have a scheduler which schedules threads, not processes, because there's only one process, obviously. Memory management, so specifically demand paging and memory mapping. It turns out that memory mapping is really important for certain kinds of JVM applications like Cassandra, which is a really popular NoSQL database, which just basically bypasses the JVM and relies on operating system memory maps for performance. We obviously support networking, and we have a full file system. So we took ZFS, and basically it means that you have a full-fledged production quality file system in the operating system. APIs. We actually support Linux system calls, although system calls don't exist in a traditional sense. They're just normal calls. But we go to great lengths to actually fake that we're Linux. And this is for compatibility reason, because we run unmodified OpenJDK. We want Uname, for example, to say, advertise that we're Linux, and we actually have a specific Linux version, which I don't remember anymore. But this basically means that the application doesn't actually even know that it's running on top of OSV. The core image has a full, well, not a full, but it's actually quite complete libc implementation. It's based on something called Mussel, which we took, but we have extended it quite a lot. There are some OSV-specific APIs. We're not trying to build our own APIs just because, but for things like MMU, which there are no POSIX equivalent APIs, we have come up with some of our own. Architectures, OSV is a pure 64-bit operating system, obviously being written just 1 year ago. We currently run on 64-bit x86 on top of KVM, and I was about to say Xen HVM, but someone at the Xen booth told me that it's actually Xen PV HVM. But in any case, that runs on Amazon EC2, and that actually the public cloud stuff is really driving our efforts at this point. We have some Xen PV stuff, but it's really incomplete. There's a guy in the audience that probably you can talk to if you want to help out. We are doing work to support VMware and VirtualBox. It's mostly just device driver stuff, actually. And are planning a 64-bit ARMS port. I think actually some people are already looking into it, and we would love to support other architectures as well, but it's patches welcome at this point. A little bit about the status. Like I said, we run unmodified OpenJDK and have tested most of the sort of major JVM languages, so Java, JRuby, Scala, Groovy, Clojure, and the JavaScript implementation in OpenJDK 7. I think they probably changed to new implementation in 8. In case I forgot your favorite language, please test it and let us know, and if you find any problems, we will fix them. Two major JVM applications that we're using for testing and performance tuning all the time is Cassandra and Tomcat, and they're actually quite different from workload perspective. Like I mentioned, I'm personally been working with Cassandra quite a bit, and it's actually seems to be mostly operating system memory management related stuff that needs to be done to actually get it working well. Tomcat obviously more on the networking side. Yeah, and although Claudius has a really strong JVM focus, the core OSV, there's nothing JVM specific about it. And actually, someone already ported mRuby, which is a minimal Ruby implementation on top of OSV. And I would personally love to see someone port Node to OSV, because Node is cool, then OSV would be cool as well, right? We support native applications. Of course, you don't get the kind of sandboxing as you get with general purpose operating systems, but we work quite hard to get memcached work really, really well on top of OSV. Yeah, and someone is using HR proxy. I think might be even using it in production. I was planning to do a demo, but apparently my laptop resolution isn't good. But you can just go and download OSV yourself and see the sub-second boot times with KVM. With Xen, we're a little bit worse than that. Yeah, I was just planning to show you how quickly it boots to OSV, but I'm going to skip that for now. If you're interested, I can show it to you from my laptop. A few words about performance. I didn't include any numbers here because they change all the time, but if you're interested, just send me an email and I'll share the results to you. We're actually running performance tests all the time because performance obviously is a major concern for us. We do outperform Linux in some quite interesting benchmarks. So when I say Linux, I mean out-of-box Fedora running in a virtual machine. We haven't tuned it at all. Obviously, people can tune it more, but this is, so for OSV, it's one of the key points is that it auto-tunes itself, and the out-of-box experience and performance needs to be there. So it's, in some sense, maybe a little bit unfair, but that's what people are running in production. So spec JVM, and that's really interesting because it's mostly about JVM performance, but we are seeing something like 2-3% improvement across all the different benchmarks, which is basically a collection of different benchmarks. Memcached, I think it's even 50% faster for the single CPU case, and we're actually doing work to re-implement parts of Memcached to really show what you can do with OSV when you completely abandon the sort of POSIX model. And NetPerf, we have really good networking results. I will talk a little bit more about them when I talk about net channels. We are roughly in the same ballpark with Linux, out-of-box Linux with Tomcat and Cassandra. Yeah, like I said, less than 1 second boot time. In the QEMU case, this actually means also the QEMU. I think it takes 1.1 seconds to bring up the whole mRuby stuff. And yeah, the final thing was just taken from Avi Kiviti slides, but this is what you would expect because there's no overhead. We are 4 times faster than Linux in context switching, obviously. A little bit about image size. So the minimal OSV image, which includes the kernel services and libc, is 70 megabytes. And that actually includes the CFS, and it's basically also a CFS image, so it includes also the CFS file system metadata stuff. mRuby image is 29 megabytes. And I was really hoping to show you nice default OpenJDK numbers, but they're really horrible. Part of it is that OpenJDK itself is quite big, and we have some sort of an issue with the CFS intent log just generating a lot of unused data in the default image. But anyway, we're working on fixing this, and it shouldn't be more than 127 megabytes plus the 17 of minimal. So how are we different? How is OSV, or what kind of things can we do with OSV now that we abandon a lot of the design assumptions in traditional general purpose operating systems? So networking channels. Actually, people tell me that there's something similar in BSD called NetMap or something like that. But in any case, this was proposed by Van Jacobson, the father of TCP, in 2006 for Linux. And I'm not sure what happened, but it never got merged. And he was able to show really nice overhead reductions, even with just his proof of concept implementation. So 25% for 1 CPU case and 20% for the 2 CPU case. And basically, the whole idea there is that you want to redesign the networking stack to avoid locking and queuing and accessing a lot of memory. Anyway, so we have now work in progress network channels implementation in OSV. We haven't merged it yet, but the patches are on our mailing list. And one key point in the net channel stuff was to actually move protocol processing to user space. So we obviously, having moved user space to the kernel space, we were able to do that. So the net channel is directly connected to application. And it's really interesting to see that we're seeing already 30% throughput improvement in, I think this is NetPerf TCP tests, jumping from 36 gigabits to 47. And the setup here is that Linux is running with the host, generating the load, and OSV in the guest receiving the packets. Something quite different related to our JVM stuff. JVM ballooning. Ballooning is a really typical technique used in virtual machines, and we're extending it to the JVM. So the idea is that we can auto-tune the GC heap and give all the memory, all the VM memory to the JVM. So you don't need to limit the amount of JVM memory to maybe something like 80% of the VM size or whatever. And then we're able to steal memory from the JVM when the operating system encounters memory pressure and needs it. This is running on top of unmodified JVM, and it's actually quite fascinating because the generational garbage collector moves stuff around. So as we steal memory from the JVM, the memory we just stole can be moved somewhere else. There's actually a really nice presentation by Glauber Costa on YouTube if you're interested in the details. Then the final thing I wanted to mention about these features we're able to do, since we have access to the MMU, one thing we're trying to optimize is to modify the JVM to replace GC card tables with memory mapping tricks. GC card tables are basically a data structure for keeping track of references from old generation to young generation. But in any case, this is something that we're working on. We haven't published anything on it yet. It's not really a new idea either. Azul, with their pauseless GC C4, do really similar tricks to reduce pause times, GC pause times, but they require some out-of-tree Linux patches, and I think they actually tried to submit those for Linux, but because they're basically doing this really crazy MMU stuff, it's really hard to get it in. Yeah, that's for my part. Zach will continue about configuration and management.
Hi, I'm Zach, or Tzach for anyone who can pronounce it. So what I want to show next is, unlike Pekka, which only shows things that work to some extent, what I'm showing here in the next 5 minutes is more of a planning that we have. And we are trying to look at what makes a cloud OS, in this case OSV, different than a traditional or a general purpose OS from an administration perspective. So if you look at any operating system like Linux, it's very oriented to a command line interface, to the CLI. I would say that other operating systems are focused on GUI, even not on CLI, but let's put that aside. CLI is basically for humans. It's made for human interaction. You can interact with it, and it's fine when you have a standalone system. When you have 100 or 1,000 server on the cloud that you want to administrate, of course, CLI will not do. So what we are doing with OSV, we're very oriented toward the API and toward mass number of server. Other aspect of the OS that are trying to handle is configuration, for example, and basically take out everything which require human interaction. If you look, for example, at configuration of operating system, you have in many cases multiple file in multiple area of the file system, sometimes each of them with different text format for the configuration, and you need to go and manually update a lot of them to do anything useful and configuration change. As you know, there are a lot of nice tools which help you solve this problem. Chef, Puppet, etc. help you do a lot of this stuff, but this tool work very hard actually to try to convert the human factor of it and make it automatic, because they will parse the response that the machine gives them back and try to extract the information from there, and it's pretty challenging. What we are trying to do in OSV is take this redundancy away and take the complexity away by doing everything automatic through API. So we choose to have REST API to basically doing everything in our system, and I will touch on that a little bit later. And if we look at what exactly interact with the cloud OS, and by the way, I guess this diagram can apply to any operating system which live on the cloud, not specifically to OSV. You have a bunch of services that interact with the operating system and with the application running on it. So you have configuration, you have packaging, I will touch on those two in a second. You have metering and trace and login, which collect information from the cloud instances. And you have what I call operation, maybe not the best name, basically API, which allow you to do stuff on the system, reboot the system, change configuration, install software, whatever you need to do on the system. Okay, I hope you can see the screen capture. So as I mentioned, we chose to do everything or to automate everything in OSV with API, and we chose REST API for it. Every operation that will be you can do on the system will be exposed eventually through API. It's not there yet. Right now, you still need to do a lot of stuff manually or through the CLI, but hopefully very soon. And I welcome people that want to help us to do that to join the project. We'll have everything over API. We choose to define the REST API with a tool called Swagger. Everyone here is familiar with it? a few. So it's not related directly to OSV, but I recommend to check it up. It's a really cool tool that allows you to define REST API, and a side effect, it's give you a cool GUI which interact with this REST API. You can see some capture here, or you can go to the Swagger and see a lot of other example. So everything that you want to do with the OSV, you can do with REST API. The Swagger API, just a layer on top of it. You don't necessarily need to use it. One tricky thing in performing operation on an operating system, that not everything is synchronic. So if you want to do something like probing the CPU or probing the disk or something like that, yes, you can have a request, get a response back. But if you're doing something like run a test or doing something which take more than a trivial, I guess a few nanoseconds or millisecond, you can't respond immediately with the answer. So we treating it like it's asynchronic. And what we will do, we'll respond automatically with an HTTP response, but the result will dump into a log file, and you can collect the result from a log file. We'll also planning to use, and it's not there yet, plan to use a synchronization token, a reference number, which will allow you to continue and follow this specific request as it executes. Oops, sorry. Configuration services. So I don't gonna go over everything in essence of time that we don't have much of. But basically, we're handling configuration as API. All the configuration change will be done through the API that I mentioned earlier. With the API, of course, come authentication, come tracing, will come transaction, etc. You will not be able to do any configuration change directly on the file or anything like that. So everything is controlled, everything built for automation, and at least I found it much easier to maintain. Packaging services, for some of you it might look familiar. Let me complete this slide and you can tell me what it reminds you. So to help people get into OSV and to help people using OSV, we are planning a public repository of OSV images ready to use. You basically have two ways to use. If you want to install your own software into OSV, you have two ways to do that. One way is to build to add your module into the build system. And if you look at our Git, there is instruction of how you can do that. The other way of doing that, you just copy the Java file or the binary file and deploy it into the system itself. To make it even easier, what we are planning to have is a public repository of images which you can pull and run immediately, or you can modify and upload it again to this public repository. What does it remind you? Similar to? Anyone want to guess? Okay. Docker, exactly. Thank you. So yeah, it's very much inspired by the way Docker handles images. So we took the good thing out of it. These are some of the operations that supporting or will support this kind of mechanism. By the way, if we have time, we'll touch on container later. And nothing that I'm showing here is specific to container. What we actually inspired by Docker is the easy management of images that are using there, which is great. Log and traps is really something that we are only starting with, so you don't see an actual implementation, rather a list of options. But definitely everything that is installed on the cloud, it doesn't make sense to pull and push all the logs locally. It will be collected by a central service and handled there. A little bit on our roadmap. So right now, I think we are about here in this graph. So it's mostly shown what we did, but we think that we are planning to do really in the next few weeks even, or the next few months. So we have an upcoming release, which will be an alpha release, which will include a lot of, I won't go to each of these features because it's quite technical, but from hypervisor perspective, we are planning to support Google Compute Engine, VMware, and VirtualBox very soon. And for the rest of them, just join the mail list and see everything which is going on there. So that's configuration, and back to container.
Yeah. Yeah, so one final thing I wanted to talk about, since I think we have the time. is containers. A lot of times when I mention OSV, people just say, "Hey, we already have containers, so what's the point?" And to be honest, containers, well, especially Docker, is awesome. It's really has done a lot to make the container stuff usable. Having been also involved in Linux kernel development, I can tell you that the control groups underneath aren't as awesome as Docker. But with containers, what you get is really fast boot time, basically zero boot time, fast provisioning, and raw performance. Under the hood, it's technically quite different from what we're doing with OSV. So containers really reject the idea of a hypervisor, and they're built on shared kernel image, which can also be a problem when you're upgrading the kernel or when you're doing hardware maintenance. So you basically don't have any of the virtualization goodies like live migration. There's a lot of complexity in the kernel. Sometimes I'm surprised it even works. And it uses a copy on write user space, which is really great for saving image space, but it's still, you're basically tied to the normal Linux user space. So what I tend to think is that in OSV we're trying to sort of combine best of both worlds. We are also able to provide fast boot times and fast provisioning and raw performance because we're cutting down layers. But on top of that, you get all the virtualization stack features that sort of you would expect. And like I mentioned earlier, you basically have hardware access, specifically MMU access, which is interesting for certain applications. And for this as well, there's a great blog post by none other than Glauber Costa, who I heard is actually in the audience today. But yeah, that's it. Do we have time for questions? If we have questions. 5 minutes?
Are you planning to support instruction there for running or different kinds of applications? For example, if you want to run the Python runtime directly in OSV, because right now you have support for OpenJDK.
Yeah, so the question is that are we planning to add stuff to support more runtimes? So we do support OpenJDK, that's our focus, but we do run the mruby runtime. And we are adding so it's basically about adding these POSIX APIs that are required by the runtime. And yes, we almost certain Claudius won't probably be working on different runtimes in the near future. But if anyone is interested in porting, send patches, and we can probably even help. And what we are doing is we are adding POSIX APIs and different APIs just to make it compatible. So I guess the answer is yes. Yeah?
For example, what would be the challenges to support other runtimes? For example, threading models or things that are maybe very specific to the POSIX API. How could you guarantee that normal applications that run now without any modifications in a container like Docker, how could you guarantee that they run?
So that, we obviously cannot guarantee that because we don't have fork. So if your application does fork, then then you need to do something to the application to run on top of OSV. But as for threading model, it really from application point of view, it looks like you're running a single process Linux or single process on Linux. Yes, the numbers are run on top of KVM. That's for us, it's mostly a convenience thing because obviously everybody's laptop has KVM installed on it. And for net channels, I think Avi did KVM first and hasn't actually even done the extend part yet, so we don't have those numbers. So the question was if we only have one process, how do we do runtime debugging? Actually, GDB is really well connected to or integrated with QEMU. So it's actually, being a Linux kernel developer, it's actually easier to debug the whole thing under a VM than a Linux one. So it's basically, yeah, well, okay, obviously you have things like memory corruption, possible memory corruption in the kernel data structures caused by the application. That so obviously can happen, but it's for us it hasn't really been any issue at all, because you can always take like the OpenJDK, run it in Linux with Wargrind or whatever, and once you're satisfied that that's sort of working properly, then you just take it into OSV. Any more questions? I guess not. Thank you.
John. Can you guys hear me? Yeah, looks like so. Hi everybody, I'm João Martins.